In this video, we're going to do a problem that's similar to question 1 from homework 11.2. The directions are to solve the equation x squared minus 6x plus 5 is equal to 0 using factoring or the quadratic formula, whichever is appropriate. We're going to do a similar problem on Scratch, and we're going to actually do it both ways, one way by factoring, the other using the quadratic formula. All right. So here is our problem. X squared minus 3x is equal to 2x. I am going to solve using factoring. Now remember that when you are solving using factoring, you're making use of the zero product property, which really just says that if we have an equation in factored form, however many factors there could be 3. If it's set equal to 0, you know that this is true when each one of the factors is 0, right? So notice that this equation is not set equal to 0. So I'm going to subtract 2x from both sides, and maybe I'm going to even, if you have a hard time lining things up, you can highlight that equals sign and line up any like terms, which we don't have any. X squared and minus 3 are not the same kind of term as minus 2x. So we have x squared minus 2x minus 3 is equal to 0. Right, so that's what we did right there. And that language is a little strange. Set, it sounds like you would just say equals 0. No, that means get 0 on one side of the equation. Now we're going to go ahead and factor. I'm happy with this problem. My leading coefficient there is a 1, so I know this much of the story. I know x times x will give me x squared. X times x gives me x squared, and now I'm looking for two things that multiply together to give me negative 3 and add up to minus 2. I know one of these things is positive and one is negative, because they have to multiply together to be a negative, and I want the 3 to be negative and the 1 to be positive, because minus 3 plus 1 is minus 2. All right? So now this is true when each factor is equal to 0. When x minus 3 is equal to 0, we'll have a true statement. Also, when x plus 1 is equal to 0, we'll have a true statement. Right? So what we did right here is we factored. And right here, we're using the zero product property. Right? And then we solve those two equations separately. Adding 3 to both sides here, we get that x is equal to positive 3. Subtracting 1 from both sides here, we get that x is equal to minus 1. Either one of those numbers will work. Okay? Now, an alternative method is to use the quadratic formula. Method 2. All right, and the quadratic formula, it says that solutions to some amount of x squared plus some amount of x plus some number equals 0 take this form. x is equal to -1 times b plus or minus the square root of b squared minus 4ac all over 2a. These are two numbers here. There's x is equal to -b plus the square root of b squared minus 4ac all over 2a, and the other number is -b minus the square root of b squared minus 4ac all over 2a. We write that concisely with that plus or minus symbol. So here, a, b, and c are numbers. A shows up there, B shows up there, we have an A here too, and C. Okay, so let's use the quadratic formula on our problem. Okay, so I just copied the problem from up above. The first thing that we need to do is we need to get this in this form. A specifically is the number with the x squared term. The name for that, if you recall, is coefficient. So a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the coefficient that doesn't have any x. It's what we call the constant. All right, so let's go ahead and start similarly to how we started on when we were going to factor this. Not going to lose track of my equal sign. I'm going to go ahead and subtract 2x from both sides. So now I've got it in the form x squared minus 2x minus 3 is equal to 0, right? The quadratic formula says that if you've got it in this form, these are the solutions. You don't have to bother factoring, right? And the number that's in front of x squared is a 1, right? 1 times x squared is x squared. Minus 2x minus 3 equals 0. Right? So we still start that same way. Set equal to 0. All right? And now we're going to identify A, B, and C. A for us is 1, B is minus 2, and C is minus 3. Identify. I lost my gray. My A, B, and C. Okay, so we can see here that A is 1, B is -2, and remember who the negative belongs to, right? We announce the sign of things. -2 is coming through the room, coming into the door. C is -3. Maybe I'll put that, scooch this guy down. All right, and now we want to plug into the quadratic formula. Here's our quadratic formula. All right. And I'm just going to make a little note here because the concept of plugging in, you guys all understand, but it's actually doing the computation here and simplifying this, doing our order of operations, all that. That part is where we run into mistakes. So if you have a difficult time plugging in, I recommend that you write the quadratic formula this way. Okay? So I'm just going to rewrite the quadratic formula. If simplification is a difficult thing for you, write it this way. That negative is a -1 times b. And don't even bother writing the plus or the minus. Just write the plus. And once you've simplified, then go, oh yeah, there's two solutions here. There's also the minus. That helps a lot of people. The square root of b squared. So around each number, I'm just going to put parentheses. B is what's being squared. Also, anytime there's a subtraction sign in a formula, it's an opportunity to make a mistake. So I'm going to say plus a -4 times A times C. All over 2 times A. Right? So here are my A's. Here are my B's. Got the first B already, and C. All right, oops, pink. There we go. Right, so all I did is I reminded myself that that minus sign is a -1 times. I reminded myself that -4 is plus a -4 times stuff, and I put parentheses around each of the letters to help myself input. And this is totally optional, sometimes it just is visually overwhelming to see the plus or the minus. And if that's true for you, work with just the plus and then come back in and write the or minus. All right, so I'm going to go ahead and plug in here. We have specifically that my solutions are x is equal to -1 times b. B is -2. I think I'll use parentheses there. Plus or minus the square root of b squared -2 squared. That's a -2 times a -2, which will be +4, plus a -4 times A is 1, times C is -3. Get my color going. And that is all being divided by 2 times A. And A here is 1. Okay, and then we will simplify. So we've got -1 times a -2 is +2, plus or minus -2 squared is a -2 times a -2, which is a +4. The number that goes here will always be positive because something squared is positive. And then we're going to add -4 times 1 is a -4 times a -3. That's a +12. We're adding +12. In other words, we're just adding 12. Divided by 2 times 1, which is 2. Right? So now we've got x is equal to 2 plus or minus the square root of 4 plus 12. 4 plus 12 is 16. The square root of 16 is 4. Oops, I said it, but I didn't write it. 4 divided by 2. And remember, these are two different numbers. This is x is equal to 2 plus 4 divided by 2, or x is equal to 2 minus 4 divided by 2. The plus or the minus. So here are our numbers. X is equal to 2 plus 4 is 6 divided by 2. 2 minus 4 is minus 2 divided by 2. Here we have it. X is dd, division by my denominator. 6 divided by 2 is 3. Or x is equal to minus 1. And those are the answers that we got here. 3 and minus 1. Now you might be saying to yourself, oh my gosh, factoring was so much easier. This quadratic formula seems like a lot. Now, the reason why we need the quadratic formula is because not all of our quadratics are factorable. And sometimes we're going to get answers that have crazy square roots in them. Sometimes you're going to get answers that have the imaginary number I in them, in which case the only way we can solve this is with the quadratic formula. Right, so we did a different problem than example 1, but example 1 could be done either with factoring or using the quadratic formula. Here they're helping me. There's 2 different numbers that x could be, and you're going to be putting them in there and there separately. This concludes our video of an introduction to the quadratic formula.